Hello, and thank you for downloading this latest Data Science Central podcast. This is Bill Vorhies, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. Today's podcast is being sponsored by SAS, and we very much appreciate SAS's support of the Data Science Central community. We're honored to have them sponsoring our event today. Today's podcast will be about 15 minutes long, and we have one speaker that I'll introduce in just a minute. And today's talk is entitled AI and Deep Learning at SAS, Part 2. Now, our speaker today is Vasil Uhnyuck, who is a software engineer at SAS, where he's primarily tasked with developing different deployment solutions for AI applications. His background is in full stack and mobile development, and Vasil holds a BS in computer science from North Carolina State University. So Vasil, hey, thank you for being with us today. Now, in today's Data Science Central podcast, we'll continue to explore the hot topic of AI and deep learning at SAS. And we'll discuss how the SAS platform enables the development of AI applications and how SAS customers are using this exciting technology today. So Vasil, with that, whenever you're ready, you can take it away.
Thanks, Bill. So to start off, I want to go over something that people are the considerations for AI products, and something SAS has looked in, or the 5 topics that SAS has looked in deeply while going or in creating SAS VIA, which is our AI base. So algorithms and tools. Something that AI products need to have is to support a lot of different algorithms or like deep learning support. An example for that is like computer vision and chatbots and stuff like that as well. Tools and ease of use and how effective they are very important as well. This is something that SAS took into account while building out the SAS platform. Another topic that gets brought up constantly is how to manage the different data that you're using when training your different models. Like some models in production would require hundreds of thousands of data sets or data points that would be used for training. And it's very important not only to manage that, but also that the AI product that you're using can actually support that massive information. So that's something important to keep around. It's not just like a science experiment. You need something that's stable and can be supported in production. Another topic that's brought up is the integration deployment piece. I feel most at this topic because it kind of focuses on developers and the people that actually put the models that data science create into production. So when you're using a platform to train models and hold your data, you also want like a seamless process to get those models into production, and that usually involves developers that will actually create the implementation that will actually get value back from those models that data science have spent so much time creating. And the things that I and others worry about, it's like how easy is it to adapt to these different ways that you will integrate these different AI products, and how effective are they compared to what maybe was done before? So it's kind of like an adapt trade-off. Another topic that kind of compares to what I was saying for integration deployment is for expertise. Ease of use is an important topic when adapting to or adopting a new AI product. Even if there is a lot of good use cases or effective use of a new AI product, it might not be adapted because it's not easily understood or there's too much learning curve associated with it. And then also assessment and monitoring. There's definitely more regulations now regarding how your data is being used, and it is important that not only are data scientists able to like assess and monitor how their models are doing, it's also important to monitor like how your data is being used and to make sure that no specific regulations are being broken. And that's another piece that an AI product will help you accomplish. Yeah, and this is all these 5 topics are something that SASFire, the SAS as an AI product, has been looking over. So going back to integration from the previous slide, the way that SAS has allowed integration to be able to be easily adapted is by providing an API in lots of different languages and different platforms. So then different developers aren't restricted, or even data scientists aren't restricted from how they want to build their models or how they want to actually do the deployment piece after the model has been created. Some examples of that is Python, Java, and REST is using a REST API to directly talk to the CAS engine that is like the heart of SASFire. Is with REST you're able to actually use pretty much any modern language, even if we haven't developed a direct API to it. Being able to use REST calls, you're able to still use all those different CAS capabilities within that engine. And that usually is a way that even if you're kind of not ready to take on a new platform, if you're already using like a REST APIs within whatever product you're working in, this is an easy way that you could adapt SAS as well. So to go more in depth into one of our APIs, so for Python we have DLPy, which is a product that helps data scientists develop out, or not develop, train different models that are more associated with like deep learning, like computer vision, stuff like that, and it helps you monitor your different models that you're making and also see like different features that are actually being picked up as you're going and training through. It's very similar to Keras, but the reason it was implemented a similar way is because we wanted it to be an easier way for data scientists to adopt the SAS platform, so then they could easily integrate it into developers as well, because if they are familiar with the way that the SAS platform works, it makes it very easy to use DLPy and produce a binary or something that's just encapsulates the entire model and just have it easily be retrieved by a developer that's also using that same SAS platform. And in that way, you're able to easily, or not easily, but through a more standard pipeline, get a model out into production. So there's multiple ways that you can actually get your model out into production and have it as be able to be used by multiple users. So it really depends on your use case, but a typical path that you would take is you would train some kind of model using DLPy or CAS or the actual SAS engine that is provided. You could use pre-trained models in the open source world, for example, YOLO, and you would be able to produce an A-store, which is like the binary model that I mentioned earlier. And once you have this, which usually takes several iterations to actually come up with a store that is ready for use in the real world, you would have a way to use that model or get output by scoring or by providing certain data into this A-store and getting output that's meaningful back. One way is you could have use the CAS engine server to use like a REST call that has an A store sitting in that server, and you could retrieve that output back. More commonly, though, is you would want to have some kind of way to have streaming data and to make decisions or to get some kind of output in real time as data is coming in, and then there's not as much of a lag back. But the negative to that of using the CAS for that is because there would be too much time to get from the client and the server. So SAS ESP, which is event stream processing, allows you to actually install this ESP engine on the edge, or like think of a manufacturing plant. You could put it like to track how a different robotic arm in a manufacturing line is acting, or you could maybe do anomaly detection, see how likely it is that something would be breakdown, so you could capture an issue before it happens. And that would be happening in real time instead of having some data being collected and then sent overnight or something like that and ran in batch. So those are some examples of how you could actually get it from, a data scientist who's been working on a model, and then eventually actually getting it output and getting value field. And with that, Bill, if you have any questions, I'll hand it off to you.
Well, yes, and Vasil, hey, thank you for a great presentation. I am interested. You talked about deployment. Can you talk a little bit about the ability of the SAS AI platform to allow us to embed applications in our working product, and give us some examples of what those applications might be?
Yes, sure, Bill. Yeah, I did go over ESP a little bit, but I think I can go more in depth on exactly how these different embedded AI applications are being used. So, for example, for ESP, we have an ESP Pi package that you could use Python to talk to ESP through a publisher-subscriber architecture, which helps send info back and forth between the CAS engine that's already installed on-premise or whatever on the edge that you're making these calls back and forth from. And then you could like use, for example, a Raspberry Pi or something to trigger a certain action, maybe like send out an alert, or consider like an actual rule action that would happen in a manufacturing firm, like for instance, maybe if you're doing defect detection or something, you could move a defective item off an assembly line, because in real time you were able to send that information back and forth. After scoring through the model, you're able to make the decision correctly. Yep.
Well, thanks. That was very clear. We all want to make our lives easier. Can you talk a little bit more about how the SAS AI platform makes it easier for developers to access deep learning and AI capabilities?
Mm-hmm. Yeah, I can think of three things that jump up in my mind. When I think of directly for developers, how does SAS make access deep learning AI capabilities easier? The first thing is it does not restrict developers to a certain programming language. It has multiple SDK supports and supports REST as well. The second thing is developer does not need to learn everything about the backend or like the CAS engine. They just need to learn how to communicate with it through the API. And this could help make implementation quicker, and the learning curve is much more gentle or not as steep. The third thing is the developers don't really need a data science background, and they can still produce models that they can test in their development environments using like DLPy, for example, that I went earlier. They could take an open source model, spit out an A store through DLPy, and then easily use that model that they've created in their application that they're creating as a developer.
Well, Vasil, hey, thank you for that was a very interesting discussion. And I'd like to thank SAS again for sponsoring our podcast today, and particularly our speaker, Vasil Uhnyuck, for his insight into today's topic. This is Bill Vorhies. I'm very pleased to have been your host for today's event. I look forward to seeing you all again at DSC's next podcast. Have a great day.